Hello everyone, I'm Harish and I'll be presenting our paper titled ASOP, Abstract Encoding of Stories, Objects and Pictures. In this paper, we create a novel dataset that captures the creative process associated with visual storytelling. We propose new tasks that demand true multimodal reasoning from models, and a novel neural composition model that models the coevolution of textual and visual concepts for narrative understanding. First, let's see why it is important to study visual stories. Humans often think and communicate in terms of narratives. Through stories, we encode shared knowledge, common sense physics, human psychology, and morality. Story comprehension involves construction of rich mental models to answer questions about characters, spatiotemporal attributes, motivations, and causality. AI systems that can comprehend multimodal stories find numerous applications in automatic storyboarding, providing causal reasoning to conversational assistants for creative tasks and to build world models. Visual story comprehension requires aligning text with visual information. There are many related works in the language vision literature. However, they mainly focus on extracting factual information. Image text understanding ignores temporal information, while videos are encoded as a single whole entity. Text is highly descriptive and structured, and scene or story creation given abstract text is unexplored. Though visual storytelling with the introduction of the VIST dataset encodes narrative text and temporal information, the dataset is shown to have incoherent stories. The acquisition process and the problem formulation model storytelling as a perceptive process. The usage of real-world images demands models to acquire all-of-world knowledge. We adhere to the following principles for development of ASOP to overcome limitations of existing work. Firstly, we prioritize creativity over perception. We bound the visual world by using clipart-based abstract images. We obtain causal and coherent narratives. Stories in a dataset are made of 3 image text panels. We also get a title and a genre from a preset list of genres. Images are composed by placing clipart-based objects in various positions and poses to form a visual scene. We modify and use the web interface from the abstract scenes dataset by Anton Lethal. We combine cliparts present in abstract scenes dataset with our own to get an abstract world made of multiple background scenes, named characters, animals, large and small objects that suit common indoor and outdoor scenes. Since visual and textual parts of the story are created together in ASOP, we get causal and coherent stories. This is a fantasy story that talks about clones. Even with the limited number of objects, the diversity in the creation is impressive. To compare our dataset with VIST, we perform a coherence test where we choose 200 random stories from ASOP and swap 2 of the 3 image text panels. Workers are shown the correct and swapped stories and are asked to select the correct one. About 97% of the stories were identifiable in ASOP. However, only 65% of the stories were correctly identified in VIST, only slightly higher than random guess of 50%. To test diversity in our dataset, we follow prior work that shows percentage of verbs as an indication of diversity. ASOP has more verbs similar to ANC, which is a corpus used as reference for human language usage, while other datasets, including VIST, have limited verbs. Moreover, prior work shows that there are more visible and descriptive verbs like sit compared to invisible and abstract ones like worry in existing datasets. The ratio between sit and worry is 2.5:1 in ASOP, close to that of ANC. Other datasets have significantly more visible verbs. We propose the following tasks that demand true multimodal comprehension from models. In the assistant illustrator task, one visual panel is masked and the model has to generate the masked panel. In assistant writer task, one textual panel is to be generated by the model. Note that the missing panel need not be just the last one. In our model, we represent an image as a sequence of object representations. Object representation is a combination of an object's ID, its attributes such as location, pose, expression, and its name. In assistant illustrator task, a masked image consists of one special masked object, and we get the sequence of object representations. They are then passed through bidirectional GRU to learn plausible visual sequences, and we finally get each object's learned state and the overall visual context. Similarly, in the text encoder, we pass the word representations through a bidirectional GRU to model coherence within the text. Next, we apply cross-modal attention to ground the visual and textual concepts in the alternate modality. The object decoder is initialized with the encoder states. Object GRU keeps track of the objects predicted so far. At each time step, the next object is predicted given the current GRU state after cross-attention over all words and objects in the story history. The first object predicted is the background scene. The attribute decoder predicts location, depth, pose, and other attributes of each object and is similar to the object decoder. The scene GRU keeps track of the composed scene so far and is used to predict the attributes of the object predicted by the object decoder. Both decoders work sequentially at each time step. For assistant writer task, where missing panel is text, the attribute decoder is absent and the object decoder simply predicts all the words. This is an example story from the test set. For this story, the last visual panel is masked. This is the ground truth story. The animals have run away and Harry has come down. The scene depicts the text in a coherent and appropriate fashion. The proposed model learned that the animals have ran away in the final panel and is able to retain the position of all the trees and objects coherently. Human baseline has missed the animals running away. Though this is a one-off mistake and we generally observe that human baseline performs way better than our proposed model. For more quantitative and qualitative results, examples and additional experiments, please refer to our paper. Thank you.